Hello, Anselm Griffin here with another YouTube tutorial featuring Matlab. Today I'm doing stiff differential equations in Matlab. The example I'm using today I found in Clev's corner, and you may care to look at Clev's method. I did it a slightly different way. Clev, used in particular here options, and I didn't use any options, so it might have been wiser to use the options, but for my students, I don't use options, so you may care to look at that. So we're just looking at stiff differential equations today. And if I just highlight this bit here, I assume you know what it is. If I just highlight that there. So there are equations, but they vary slowly, and there's others that vary rapidly. So the numerical method, the ordinary differential equation, must take small steps to obtain satisfactory results. So I did it in Matlab, and here is the published version here, and we're looking at flame propagation. Highlighted there. So you light a match, it combusts, and there's a critical size, and then when you light the match, it remains at a critical size. So the FDT is f squared minus f cubed. Clev wrote it a little better here. Y squared minus y cubed. Y prime or y dot is y squared minus y cubed. Same thing. I just used f. Let's look at my method. First one I did a relatively big increment, 0.01. My time span is just expand there a little bit, 0.01 in steps of HO, in steps of 0.01 to 2 over H0. So that would be 2 over 0.01, so that would be 200. Sorry for that, just moving there. I call ODE 45 the stiff differential equation. I'll show you the stiff differential equation at the end, but that's quite simple. The time span and the initial condition. The x-axis is 0 to 200 and the y-axis is 0 to 2. And I did a tick and a tock to record how long it took. It took 0.6 of a second. And I can just, sorry about that, that's just, there we are. And there it is. Now, if you go to smaller delta, so I've gone 2 orders of magnitude smaller, we're still using the same differential equation. My time span is still 0.01 in the delta and 2 over H00, so we're going to get to 20,000. Because we're going in such, sorry, it keeps jumping on me. Because we're going in such small deltas, it took 1175, that's 1200 seconds. So that's nearly 20 minutes. 600 seconds is 10 minutes. 1200 seconds is 20 minutes. So it takes a while, to put it mildly. Now, with Clev's options, he would do it much quicker. And by the way, if you're doing this in Matlab online, it times out, because I think there's a limit of around 300 seconds. There is the plot that you get with Clev as well. And then how do you get around this? You use the ODE 23 S, and S is for stiff. Same as before, same delta, same time span. We call the ODE 23 stiff method. Sorry for that jumping on me again. Apologies about this, it's just too big. There we are. And the elapsed time there was 976 seconds. Now, yeah, that'd be down about 25%. Now, not that much quicker, but still quicker than the 4-5 method. Okay, I put all of that in Word, and the Word document will be available under the description. And the only reason I'm there, just to show you this, that there is the differential equation, nice and simple, dfdh. Okay, so hope that gives you an idea, and thanks very much for listening.